Algebra 1. There we go. Chapter 8, Section 5, factoring using the distributive property. So factoring is when you are breaking a polynomial up into its factors. Factoring by grouping means that you get terms together and then you factor. And the zero product property is when one factor is a 0. So our lesson menu tells us that we have 5 examples to go through. First, we start with our quick check. So find this. We have 4x plus 5 quantity squared. So we square the front. 16x squared. We square the back. And we get 25. I need more room than that. We get 25. Then we take 2 times a times b. So we get 16x squared plus 40x plus 25. So 16x squared plus 40x plus 25 is c. Okay. 3 minus 5b quantity squared. So I take the front and I square it. So I get 9a squared. I take the b part and I square it and I get 25b squared. And then I take minus 2 times 3a times 5b plus there. So we get 9a squared, 10 and times 3, so minus 30ab plus 25b squared. So 9a squared minus 30ab plus 25b squared. B. So now we have the beginning and the end are the same, but we have a plus and a minus in the middle. So we square the a, 9x squared. We square the b, we get 16. And plus and minus, we get a minus in the middle. So 9x squared minus 16, which is d. Fine. What we have here again, our a's are the same, our b's are the same. So we get 4 c to the fourth. And 36d squared, so minus a 4c to the fourth minus 36d to the second, so a. Write a polynomial that represents the area of the figure at the right. So it's the area of the large plus the area of the small will give you the area of the total. How do you find the area? We take the area of a rectangle is equal to length times width. So this will be x plus 3 times x plus 3. If you didn't realize, it's just x plus 3 quantity squared. That's x squared plus 2 times x times 3 plus 9. Because you square the front, you square the back, and multiply everything times 2 in the middle. So x squared plus 6x plus 9. And on the small one, it's just like that, x minus 6 and x minus 6. So that's x minus 6 quantity squared, or x squared minus 2 times 6, not negative 6. 2 times 6 times x plus 36. So then you have x squared minus 12x plus 36. And we're adding these two together, so x squared plus x squared is 2x squared. 6x and negative 12x is negative 6x. 9 and 36 gives you 45. So 2x squared minus 6x plus 45. What we have done is use the distributive property to evaluate expressions. What are we going to do? Use the distributive property to factor polynomials, and then solve a quadratic equation of the form ax squared plus bx equals c. Terms that we talked about, factoring by grouping, and the zero product property. To use the distributive property to factor 15x plus 25x squared. So what we're looking for is what they have in common. So the greatest common factor of 15 and 25. So they're showing you what goes into 15. So they have 3 times 5 times x, and 25x squared, we have 5 times 5 times x times x. So what do they have in common? They have a 5 and an x. Or you can come up here and say, what number do they have in common? They have a 5. What letter do they have in common? They have an x. So then I take 15x and I divide it by 5x. My x's go away, and I'm left with a 3. Take out that 5x, I get rid of 1x, and 5 divided by 5 is 5. So I get plus 5x, which is what we have here. So the completely factored form of 15x plus 25x squared is 5x times the quantity 3 plus 5x. Use the distributive property to factor here. So sometimes when you have three numbers, it can be a lot harder to find that one thing that they have in common. So you can always go back to finding the tree, 2 and 6, 2 and 3. So that's how they came up with this. And then 24, same way, 2 and 12, 2 and 6. Notice I'm using prime numbers here, 2 and 3. And then 30, I'm not worried about the negatives at the moment. 2 and 15, 3 and 5. And so you can say, well, what all do they have in common? They have, I can circle a 2 in each one. I can circle a 3 in each one. But I can't circle anything, any other numbers. So I have a 2 and a 3. Then I have to look at letters. I can circle an X in each one. I can circle a Y in each one. So times X times Y. So 6xy is what they have in common. So when I take that out, I bring it out front, 6xy. Well, what's going to be left? A 2, nothing else there, plus 4 and a y, 4y, minus, this goes in here 5 times. I'm taking out 1x and 1y, so this is 3, so minus 5y to the third. So what's the largest number that these two have in common? So we can use the distributive property to factor the polynomial. 3 and 12, so this one's pretty easy. So 3 they have in common. Do they have any letters in common? Well, they have 1x. They each have an x, and they each have a y. So we're going to pull that out. 3 divided by 3 is 1. Take out 1x, I'm left with 1x. Take out a y, and I have nothing else. Okay, plus 12 divided by 3 is 4. X divided by x, the x is gone. Y squared divided by y leaves me with a y here. So we have 3xy times the quantity x plus 4y. Okay. And then we get into one of these bigger ones here. It's pretty easy to tell on this one that 3 is going to be the only number that goes into all of them. They do have an a in common. And they have 2 b's in common. We're going to take out 3ab to the second, which ab to the second will be gone, and 3, so that leaves me with a 1 here. 15 divided by 3 is 5. I can take out 1a in both b's, so I'm left with 5a. 27 divided by 3 is 9. I can take out an a, I can take out 2 b's, so I'm left with plus 9b. So b. Factoring by grouping. A polynomial can be factored by grouping only if all of the following conditions exist. There are 4 more terms. Terms have common factors that can be grouped together. And there are 2 common factors that are identical or additive inverses of each other. So let's look at this. So ways that we can put them together. So 2xy plus 7x minus 2y minus 7. So looking at this, you could put the 2xy and the 7x together, but then the 2y and the 7 don't really make sense. I could get the 2y with the 2xy, and I could take out a 2 and a y, and the 7x and the 7 have a 7 in common. So regrouping this to where it's 2xy minus 2y, and 7x minus 7. So I'm looking for that pattern of things that they have in common. I can take out a 2y, I'm left with x minus 1. I can take out a 7, I'm left with x minus 1. And guess what? They have something in common again. I can take that out. So I take it out front, and I get x minus 1. What am I left with? I'm left with 2y plus 7. You can have it in either order. I actually like to see it this way. Better to see what I'm pulling out front. So trying that, what do I have in common? Well, the 3 and the 15 can go together. The 20 and the 4 have something in common. They also have an x in common, so let's try that. So 4xy minus 20x plus 3y minus 15 if I take out a 4x, in this one, I'm left with y minus 5. And then plus, if I take a 3 out here, I'm left with y minus 5. So that worked. Now I have something else in common. I have y minus 5. I can take that in front. And that leaves me with 4x plus 3. So y minus 5, and 4x plus 3 is C. Factoring here again, grouping. I see a 15 and a 3, those go together. I see a 4 and a 20, those go together. Put your parentheses around them, start taking out what they have in common. So they have a 3a, that leaves you with 5 minus b. The second one has a 4 in common, leaves you with b minus 5, but you notice those aren't the same. But they're just, we can flip them around. So if we were to take a negative 1 out of this first group, that would give me a negative 3a. But when I take a negative 1 out, that makes this a negative 5 and this a positive b. So it flips to be b minus 5. And now we have something in common that we can take out, and we have it in factored form. A little trick there to getting the answer. Negative 2xy minus 10x, that seems appropriate. So I'll take out that negative 2x. That will leave me, because we don't like to have a negative in the front, that will leave me with a y plus 5 plus 3, y plus 5. So I didn't actually, I went ahead and took my negative out first, so that helped me. I have a y plus 5 in common, which leaves me with negative 2x plus 3. So y plus 5, negative 2x plus 3 is b. So zero product property, if the product of two factors is 0, then at least one of the factors has to be 0. So in other words, if a times b is 0, one of them has to be 0. Property. So solving x minus 2 times 4x minus 1 equals 0. So you check the solution. This is the meat of Algebra 1. Learning to do this is everything, because this goes into your physics, your chemistry, your Algebra 2, your geometry, solving for your 0 here. Because once you have it factored, it's so easy. X minus 2 equals 0. You do this enough that you don't even have to actually add it to both sides. You just know that it's going to be the opposite of whatever it is on the left. It's going to be x equals 2. You said 4x minus 1 equals 0. You add 1 to both sides, and you get 4x equals 1 divided by 4. So x equals 1/4. Let's see, are we checking to see if they're correct? So the roots are 2 and 1/4. Nope, there is actually something else that we can do here, but we are not there yet. So right now we just need to get used to finding those roots, and next we'll learn how to use them. Substitute 2 and 1/4 for x into the original equation. And when you do that, you find, so you put 2 in here, you get a 0, so you get a 0 out. You put in 1/4, and you see that 1/4 times 4 is 1, so 1 minus 1 is 0. So these are both true roots of our system. Let's see. So here, solve 4y equals 12y squared. If we want to solve and check our solution, the first thing we do is we get everything on one side of the equal sign. So this will be 4y minus 12y squared. Then they took out the 4y because that's what they have in common. And we're left with 4y equals 0. So solve for y, you get y equals 0. 1 minus 3y. Solve for y, you get y equals 1/3. We're going to plug them back in and make sure that they are correct. So the roots are 0 and 1/3. Check by substituting and 0 and 1/3 for y into the original equation to make sure that those are our roots. So they gave us the factored form. All we have to do is set it equal to 0. And we get s equals 3. 3s plus 6 equals 0. We get 3s equals negative 6. So we get s equals negative 2 if we plug them back in. So we would get 3 minus 3, 3s plus 6 equals 0, so we get 0, whoops, this is 3 times 3 is 9, times 15, and that equals 0. And then we would put in a negative 2, so we get negative 2 minus 3 times 3 times negative 2 plus 6 equal to 0. So that's negative 5 times, this is negative 6 plus 6, which is 0. So this one works. They don't always work out, so make sure you check. So we have a root of 3 and a root of negative 2. So B, they put it in numerical order, negative first. Solve here, so what do we have in common? We have a 5 and an x in common, so that leaves me with 1 minus 8x, set each one equal to 0, so 5x equals 0, so x equals 0. 1 minus 8x equals 0, so I can add 8x to both sides. Divide by the 8, so x equals 1/8. If we put them back in, 5 times 0 minus 40 times 0 squared is 0. That one works for sure. And then 1/8, so this will be 5 times 1/8 minus 40 times 1/8 squared. Doing this out with fractions, we get 5/8 minus, let's see, this is 40 times 1 over 64. You got to do the squared first. And then 8 goes in here 5 times, and in here 8 times, so we get 5/8 minus 5/8 equals 0. So it works out. So 0 and 1/8 are our answers. A, the space was right. A football is kicked into the air. The height of the football can be modeled by the equation h equals negative 16x squared plus 48x. So this is its arc. This is where it started, this is where it ended, and this is its highest point right here. Where h is the height reached by the ball after x seconds. Find the values of x when h is 0. So when the height is at 0. So when we start and when we end actually. What do they have in common? They have that negative 16. So that leaves us with x squared minus 4. So that's negative 16, whoops, not 4, 3. Let's see. X squared minus 3, I didn't have to do anything. So negative x. Take on the x, goodness gracious. Negative 16x equals 0. So x equals 0. That would be right here at 0, 0. Because that's where we started at. And then x squared minus 3 equals 0. Add 3. So we get x squared, not x squared. Goodness. Okay. I'll get it right eventually here in a minute. So we get x equals 3. So it's saying at 3. So we have an answer of 0 seconds, and 3 seconds is whenever it has hit the ground. So this is 3 seconds later over here. And this is 0 seconds. Okay, Juanita is jumping on a trampoline in her backyard. Juanita's jump can be modeled by this equation, where h is the height of the jumping feet at t seconds. Find the values of t when h equals 0. So 0 is equal to negative 14t squared plus 21t. We have a 7 in common. I'm going to go ahead and take out that negative, because we don't like to have it at the front. So negative 7t will leave me with 2t minus 3. Negative 7t equals to 0 gives me a t of 0. And 2t minus 3 equals to 0. I'm going to add 3 on both sides, so that I get 2t equals 3. Divide by 2, so I get t equals 3 halves. So that's 0 seconds and 1.5 seconds.